Good morning. Good morning. Glad you're here. I'm Keith Parsons. I do Wi-Fi. Follow me on Twitter, Keith R. Parsons, and let's get on with it. So, why is Wi-Fi easy to do wrong? Last year I talked about a bunch of rules about how to do Wi-Fi right. And if you do Wi-Fi wrong, it still works. It still works because it was designed from the very beginning to be super, super robust. So if you break a rule, you put an AP in the hallway, it still works. You put an AP on the wall like a clock, it still works. You take the antennas and you make them go weird, it still works. If you break most things in Wi-Fi, it still works. Unlike Ethernet, that if you cross pairs, it doesn't work. So you have instantaneous feedback in Ethernet that you don't have in Wi-Fi. So you can be doing something for years wrong, and your answer is, well, it worked. Yep, it did. That doesn't mean it's right. So you should be learning and studying to figure out how to do it right. So just because something works does not mean we should be continuing to do that. Also, don't get your information from Spiceworks. Just saying. I was thinking earlier this year about Wi-Fi troubleshooting. A lot of people come to us. We've taught 6,000 people ECSE classes in the last 5 years. It's been very successful. A lot of people come to class, they learn how to do some pretty decent things with design, and they leave saying, yeah, but I design once every now and then for a project, but I troubleshoot every single day. Do you have anything around troubleshooting? So I did some research, and Cisco has some troubleshooting techniques. Microsoft has troubleshooting techniques. CWMP came up with a troubleshooting plan, and they usually look something like this. You identify the problem. You then recreate the problem so you can cause it, and then you locate it, you isolate it, you figure out how to fix it, you fix it, and then you document it, and you say, I have now troubleshot. How would I take that? And I mean, I can teach you the flow, but that doesn't teach you how to actually fix when Wi-Fi is not working. And most of the time when people call and say, the Wi-Fi is rubbish, slow, sucks, something, not usually a good comment, does that really mean the Wi-Fi is bad? So what we need to do is figure out, how do we troubleshoot Wi-Fi more efficiently? How do we get to the answer a little more efficiently? So we would like it to be simple. Occams Razor, of two choices, the most simple is probably best. I like Occams Razor. It's a wonderful technique. He actually didn't say more things should not be used than necessary. He said it in Latin, but I don't understand Latin, so I just put the English one. But the cartoon is more accurate about what we're thinking of. It would be nice if it was simple. Answer, done. Except for we have a very, very complex issue to deal with. Hopefully you get a little understanding of how complex it is. So let's go back in time, 1935, October 30th. The US Army, at the time there was no Air Force, said after World War I, we were a little tired flying little biplanes around. There's a new war on the horizon. We need to be prepared. So they put out to bid. 4 companies came up with different types of airplanes. This is 1935, before the war even started, and said, you know, those biplanes, yeah, that's what we had before. Simple controls, easy to understand. But the new war that's coming is being more complex, more difficult, more things going on. The complexity of the flying is more. So we should get a better plane. So this one up in the upper right-hand corner was called from Boeing. The P299 was the model number they were playing with. And October 30th, 1935, in a place in Ohio called, outside of Dayton, kind of where the Wright brothers started. Today it's called Wright-Patterson Air Force Base. They took and were going to show this, Boeing was going to show off this new plane. It was the coolest, fastest thing out there. It had guns all over. It had 4 engines instead of 2. It could travel faster, farther, carry more bombs. And the Army Air Force was like, yeah, let's see this. So they took a pilot. Test pilot had been around flying for 18 years. Gets in the plane, takes off, gets up 300 feet, crashes. Kind of a bad day for Boeing. Kind of a bad day for aviation. And doing a post-mortem, actually a couple people lived, so they're like, what was wrong? And a reporter at the time said, it was too much plane for one man to fly. Too complex. Human beings cannot handle that level of complexity. Well, Boeing comes back and said, we've been flying it for a long time. What went wrong? And what it ended up being was pilot error. This pilot who had 18 years experience forgot to unhook a little button that said, lock the elevators so they don't flap in the wind. So they had a little lock they put on so they wouldn't flap. He took off and he had the lock on. And he crashed. So Boeing said, we can solve this really, really complex problem with something super simple. We use a checklist. So today, my son-in-law is an F-16 pilot. He gets in his plane, and the first thing he does is pull out a checklist. You fly on a 747, the pilot gets out, his checklist. We now use checklists because we can take super complex issues and simplify them down. Now, it doesn't mean my son-in-law didn't spend the last 4 years of his life preparing to fly the F-16. It's not like they have to be unintelligent. It's not like you don't know how to fly a plane. It's just there's so many pieces, a checklist helps. Another example. In 2001, they started applying checklists to surgeries. Hospitals who started doing this picked up 10, 20, 40, 50% lower problems or complications from surgery by just having a checklist. A surgeon with 12 years plus experience and education past graduate school still made enough mistakes. They said, hey, we should probably put a checklist. And some of them were as simple as, hey, when you start the surgery, introduce yourself to the anesthesiologist. Double check the person's name. Little things. The UN with the WHO, the Organization for Health, the World Organization of Health, came back and said, that is so important because every year, in 2004 when they first started, they were doing 230 million surgeries a year. 1 million people died because of complications from surgery. 7 million people had complications of surgery that's kept them debilitated for the rest of their life. 8 million lives totally changed because of surgery complications. Who comes up with this simple little one-pager? And they saved over 30% of those lives. 300,000 people a year didn't die because of this piece of paper. Now, Wi-Fi is complex. I thought about it complex when I first met with a guy named Badman. He's on the Twitters with @WiredNot is his handle. And he works at a university, and he was trying to explain to his corporate bosses why he was trying to troubleshoot something, and he said, you're the Wi-Fi guy. Why are you over there messing around with something else? And so he put out this little soon-to-be-famous cocktail napkin. That's his quote, not mine. And that was 2016. Now, in 2019, he is now famous. It's up on a slide in front of Wi-Fi Design Day, and it talks about the users and the client devices and the APs. APs are attached to cables, which are attached to switches, which are attached to routers, and we have all these services. Hello, I'm at a conference. Don't call me. I don't want to be rude in front of everyone else. Oh, I am. Okay. Somebody's really embarrassed now. And I looked at this and I started saying, wait, he missed a bunch of pieces. Wi-Fi is actually more complex than that. So it came up with this. This is after meeting with tens of people, asking lots of questions. What could possibly go wrong? And what we ended up doing was making little bubbles. Every little bubble represents a thing, a group of things that could be wrong. When we list them all out, there's hundreds. But we wanted to organize them. So we organized them into, well, let's start with the first person. The user, he's got some issues. Could be just that the user did something wrong. Did not flip the switch that said turn the Wi-Fi on. And so when he calls, Wi-Fi's not working. But it could have just been his fault. It could be the client device itself. It could be anything that happens in the RF medium. So the RF medium is a box, and lots of things happen in the RF medium. It could be the association process down here. How do I get associated? How do I choose which AP to join? It could be to the AP, and note the AP is bridging, AP's bridge, between wireless and wired. It could be anything on the LAN. It could be the HCP server went bad. Any of these issues that could go bad, even out to the WAN side, manifest themselves to our end users as Wi-Fi sucks. And it may have nothing to do with Wi-Fi. Hi. Are you recording? Yes. Did you ask permission?
Sorry. Can I record you?
No. That's just rude. If you're going to record, ask. But they're recording up there if you want to get a copy. Plus, that's probably a better camera than yours. So anyway, sorry, I didn't mean to tease you too. So we're looking at this saying, what are the things that could go wrong? And so we build a framework, a checklist. Where do we go to look for each thing? And then for every one of these bubbles, now this next slide, I'm apologizing for it. It's not a really good slide, but it has lots of information. We took every one of the bubbles, end user, and here's all the things that could go wrong with the end user. And it is not an authoritative list. I just couldn't get any more to fit on the page. There's 340 individual items that could go wrong with Wi-Fi or look like they're Wi-Fi. They could be something else. And we're out there thinking, oh yeah, we need to do this. So we have a new ECSE course on troubleshooting. I was going to just have a troubleshooting course alone, and someone said, ECSE's kind of got a good name. Accow's been a really good partner. Why don't you just call it ECSE Troubleshooting? So we did. So the troubleshooting class is under the ECSE banner, but it's a troubleshooting class. And we just held one this week, a couple days down in Oxford. And in one of the exercises, we have people ask questions, just to practice. When someone calls in, how do you ask a question to get to the answer as quickly as possible? And what we found was, and this was a room full of very sophisticated, experienced users, and their questions were tied to their own history. Oh, I remember there was a DSC scope problem once. So they asked a question about, do you think it's DHCP scope? Rather than using a framework that says it will fit. If you use the framework, you will find the correct answer. You don't have to personally have all the experience yourself. So Peter McKenzie has lots and lots of experience in troubleshooting. He's had so many experiences when he sees a problem, he goes, this reminds me of something I had before. But what about a new guy who's just new in the industry? He doesn't have all that experience. But we do have a framework where you can tie things to. So lots of details, and I'm not going to go through them all. In class we do, but that's what a class is for. But as a human, I'm human, you're human. Okay, I'm a little bigger human than you, but that's different. We can't touch, taste, smell, hear, feel any of our five senses, or any of our other senses like the sense of balance. None of our senses can tell us anything about RF. So in order to experience RF, we're always going to experience it a step away through a tool. So we need to have tools that will tell us how it works. Now, if I'm a carpenter, I can use a hammer and a nail, I can feel them, I can see it, and I can do it. If I'm in Wi-Fi, I can't quite do that. So I need to have a set of tools, like a clicker that clicks. So in our course, we use a series of tools. We have free tools, we have low-cost tools, and then we have professional tools. And we should go through all of them as well. My personal take, I think you should have professional tools to do everything. But there's some pretty decent free tools and low-cost tools that can solve a whole lot of your problems. When we came up with these sets of tools to play with, we said, well, how do I apply them? Do I go back to that, identify a problem, recreate the problem, and you step through that, but I still don't know how do I apply which tool to which problem? Let's look at just one snippet of the big, huge bubble chart. Let's just look at this RF frequency. Everything that touches RF. AP transmitting, client transmitting, Bluetooth transmitting in our same frequency, microwave oven in our same frequency, all of them affect the RF medium. In that, there's a whole bunch of things that could go wrong. We could have adjacent channel interference, co-channel interference, jitter going on, latency going on. How do I access the medium? And every single frame that ever touches the RF medium has to go through what I call the game. It has a contention process saying, is anyone listening? Oh, no one's there. Is it free time? Yes, I have a little bit of dead air. So now I'm going to take a random number and I might count a random number down, and then I'm going to talk the whole time I'm listening to make sure no one else is talking. No one on preamble detect, no one on energy detect. That's for every single transmission has to go through that, which is why Wi-Fi is not a very good steward of RF spectrum. LTE is way more efficient than Wi-Fi is. Wi-Fi is free. We're using unlicensed spectrum, and the chipsets are nearly free. So Wi-Fi is ubiquitous. No one said it was good. It's just here, and we have to deal with the way it works. So we took those sets of tools, and by the way, I only showed you one of these. You could go through every single bubble and have a whole discussion about what was in there, what are all the pieces. That was just tease. So for the tools, depending on who you are and what tool set you have, I like watching Mythbusters. Anybody here watch Mythbusters? Adam Savage just wrote a book, and it was, I like the title, but I'll tell you a joke first, then I'll tell you the title. The joke is, if you have a hammer, everything in the world looks like a nail. Right? So if I have a spectrum analyzer, it's the only tool in my kit, and I'm going to use it for everything. Adam Savage wrote a book called Every Tool is a Hammer. Meaning, no matter what you have, you can always make it pound on things. Now, a scalpel, probably not a good hammer. A little dangerous. But his point was, whatever you need done, you might have to pick a different tool to accomplish that one thing. Well, we took this set of all the tools that exist and say, okay, they fit in these 6 categories. We have some tools that allow us to investigate, meaning scanners. The answers in the investigate are like tabular format. So in Echo, it's the RTFM page. Insider does it. Wi-Fi Explorer Pro from Adrian does it on a Mac. On Windows, you could use WinFi. There's lots of tools that let us see a tabular format. Very useful information. You can use it to troubleshoot. And this might be your go-to answer. You have a problem, first thing you fire up is your scanner. We have measurement tools, iPerf, ZAP, TCP. We can do FTP pushes. We have validation tools. My favorite. I come into a troubleshooting thing and they say, oh, we have problems here. My first thing, what are your requirements? Find the requirements, and I go survey. Because I want to know, is the RF meeting all the requirements everywhere? If it's not, then if I fix that, then I might have fixed all the problems in one pass. Peter McKenzie's here. He'll be presenting the last session. He comes in this way from his packet capture. And he goes, if I can solve the problem with packet capture, I don't need to do anything else. You might come in with a spectrum analysis. You might not have any tools at all except for your controller, and so you come in from the managed side and say, I'm going to use my controller to troubleshoot. Any one of the sets of tools is fine. Not any one of them is sufficient. They might solve one problem, but they can't solve all the problems. So it's a combination of use the tool you have until you find all the information, and when you're done, go, oh, wait, I need to do some further analysis with a packet capture. Then you get out a packet capture tool. There is no one answer. And instead of saying, all Wi-Fi troubleshooting is this flow, I want you to think of Wi-Fi troubleshooting as taking the set of tools you have, whatever you have, looking at the framework, asking proper questions, and then applying the tool to solve whatever the problem is you find. So let's think back about how Wi-Fi works. If you don't know how Wi-Fi works, it's pretty hard to fix it. Now this is one about the RF medium, the little red box up above. If I have low signal strength, it means I have low SNR. Low SNR means I'm going to use a lower modulation scheme. The example here is BPSK. BPSK is very robust. It can punch through lots of noise, because if you understand how EVM works, I have this entire half of where the bit could go. Instead of where it is at 90 degrees, it could be 45 or 135 or stronger or weaker or anywhere in here, meaning it's very robust and it can handle lots of interference. Either interference caused by the transmitter, interference caused by the receiver, interference caused in between. Anyway, BPSK, very robust. 6 meg data rate. That's how it works. Because it is robust, it doesn't send very many bits. 1 bit per cycle. I like robust. But the downside is not very fast. Now, if it's not very fast, that means if I'm going to transmit a 1200 byte frame, it's going to take a long time. Capacity is about speed. Capacity is not about number of APs. Capacity is all about speed. Because if I have high signal strength, high SNR, I can go to a very complex modulation scheme, which means my same 1200 bytes that I have to transmit, 1200 bits, one frame, I end up doing that in less time. Because it's less time, I get on off the wireless medium as fast as possible, means I have capacity to put more people also at the same time. Wi-Fi capacity is about speed. Speed is about high SNR. High SNR is about having a high signal strength, except for my S is your N. Your S is his N. Your S is her N. And so in our network, if I boost my signal strength to help me get louder, I'm going to cause someone else to have lower SNR, which means they're going to go slower, which means we're going to have lower capacity. Which is why adding another AP doesn't necessarily solve the problem. One of the complaints we get all the time in Wi-Fi troubleshooting is there's a coverage hole. Really? In the last 15 years, I've traveled all around the world fixing Wi-Fi problems. Not once have I seen a coverage hole. Anywhere. Has anyone ever turned on your phone and not seen some Wi-Fi? Now, it might be the right Wi-Fi, it might be congested, it might have coaxial interference, it might have all sorts of things wrong with it. Lack of coverage, not really a big deal, because coverage is easy. Anybody can do coverage. They can put an AP in the hall, they can put an AP on the wall like a clock, they can turn up the power, they can turn down the power. They don't have too many APs. Coverage is the easiest of all the design goals. Making sure that we get high speed, that's hard design. But that's how we end up getting capacity. So, let's walk through just a little concept here of how a single client makes a single decision. By the way, this happens for every single frame. For every device, AP or client, every time they access the medium, they have to do this little thing. So let's say I have a MacBook over here. My MacBook can do 1.3 gig, so on the MCS chart it says I can do all of these all the way to there, 1.3 gig. My client goes, probe request, probe response, authentication response, association request, hey, AP, I can do all this. And the AP comes back and says, well, I can do all this. And we end up getting a subset. And we have a little box. And this is the box we both agree in. Maybe if it was an iPhone, I have a smaller box. Dell, I have a box up here. But there's a negotiation between what the AP can do and the client can do, and we end up with a box. Now, the first frame out, after I'm associated, association is to wireless, what a link light is to wired, triggers the DHCP request. So a DHCP discover packet leaves my device, comes down the protocol stack, hits the radio and says, can you please send this string of bits, a DHCP discover, out your radio port? And the radio goes, how should I package that set of bits? Well, I'm going to take and send it with 256 QAM. Now, the preamble is going to go out at BPSK, because all preambles are always going out at BPSK. And then I have a header, and then I have whatever my data rate that I've set is, and I set it to 256 QAM modulation. I'll also choose 5 of 6 coding, means I'm going to send 6 bits and only expect to get 5 back, so I have about a 20% spare bit, kind of from modem. We used to call them parity bits. And then I would use 80 megahertz wide channels with a short guard interval. So that's how I would package the bits. Woo, send them over the air. The AP on the receiving end is listening, and what he hears is the radio wave I sent. If he can demodulate it properly, see the whole thing, including the CRC at the end, he will answer ACK. Now, my client knows that the AP received his frame. Yay. If it works that way, we're wonderful. But what if the AP couldn't quite demodulate that frame? One of the pieces messed up. So the AP has no other choice but to not ACK. Now, by the way, in Wi-Fi, we have no NACs. I wish we did, we don't. What we have is no ACK. Not a NAC, we have nothing. So the client said, I packaged it really cool, and nothing came back. I wonder why it didn't work. The client's sitting here thinking, going, it could have been because the radio frequency was congested. That could be an issue. Okay, so it says, I will take my game where I listen before I talk and then I grab a random number. My random pool was not big enough. I will make a bigger random pool in case I was bumping into someone else. If I have a bigger random pool and they have a bigger random pool, we have a better chance of not hitting. Maybe that was the problem. And it goes, same configuration, data, no ACK. Data, no ACK. And after 3, 4, 5, however it's programmed, it goes, it's not contention. Because I just had a really huge back-off timer and it didn't get any better. Maybe I need to change to a 40 megahertz channel. Maybe I should go up. Maybe I should go diagonal. Maybe I should just run all the way up to here. And I will send out that DHCP request with BPSK, 1 of 2 coding, meaning I have 100% spare, long guard interval, 20 megahertz wide only, because if that AP doesn't ACK me now, I need to roam to a new AP. And all of that little discussion I just had is happening for every frame, accessing the medium every single time, from the AP or from the client. Some clients are smart enough to say, I need about a 37 SNR. I only have a 25 SNR. Maybe I should come down here and I'll start here. So if you have sophisticated clients, they might look at RSSI, they might look at SNR, they might look at, the last time I was here at this GPS location at 2:30 in the afternoon at my desk, the best AP was that one, and I'll choose that one instead. So how sophisticated your devices are can make this little thing go a little better. Another issue with troubleshooting, and this goes back to the first circle about the end user. Your users just spent a boatload of money. NHS just went in and installed 802.11 AC. By the way, whoever asked that question about upgrade, I still have customers today on N, I have customers today on G, and it works perfectly. You do not need to upgrade every time the new thing comes out, unless you work for a vendor who sells stuff. 802.11n still today delivers Netflix. By the way, Netflix needs 2 meg for SD, 4 meg for HD, and what is the lowest possible speed? The worst possible Wi-Fi can deliver Netflix, so get over it, man. But this one is a troubleshooting that's a human level troubleshooting. Your company just spent money and you said, we have new 1.3 gig. Yep. And even if I get 1.3 gig, only the blue is payload. Wi-Fi is very, very inefficient use of airtime. And the only thing we have is airtime. It's also the very least thing we have more of. We run out of airtime all the time, which is why you can't put 2 APs in the same channel because they share the same airtime. We didn't even get to all the authentication process, or how the AP works, or how the LAN part works. One last one before we go. If a client associates, then it's going to go through authentication, open, or .1x, or PSK. After that, it will hit a control port, and then it gets upper layers, and then it can pass traffic over the LAN, and then we get a captive portal. Pause for effect. Captive portal is the last step of Wi-Fi. Our users think it's the first step. If you get a captive portal, Wi-Fi works. If you get an IP address, Wi-Fi works. If you get on open and you get passed and you get here and you get in a PIPA address, an automatic private addressing address, a 169, Wi-Fi works. If we understand how Wi-Fi does its bit And where each of the pieces fall in line, we can troubleshoot anything. First thing, how do we troubleshoot wired versus wireless? That's a pretty big answer. So I'll just give you one quick one here. Here's from a hotel I was in. I was getting 867 meg data throughput. But when I went to speedtest.net, I got 1 meg. Do I have a Wi-Fi problem? The AP was offering 867. I was getting 867. There was no possible way I could get it better. And the beauty of the whole MCS issue is it self-announces. It self-says, I'm doing diagnostic frame by frame. I tried 256 QAM, it didn't work. I tried 64 QAM, it didn't work. I'm now at 16 QAM, and it's working. What you know is it tried and failed, so I have an RF issue. This one, I don't have an RF issue. I have a backhaul issue. So if you were going to go to the doctor, you would see blood pressure or pulse or temperature. Here, we have channel utilization, retry rates, and MCS. My personal favorite is I just check your MCS. If you have an MCS, it's telling me, just like temperature. If you have an infection, your temperature goes up. The doctor knows that. So all he does is you go in, they take your temperature. Are you sick? I don't know. But I know if you have a temperature, I'm going to have to ask more questions. So if we know MCS, we can solve so many other issues. So just to end on that, these slides are all available. If you go to this location, wmpros.com/troubleshooting, all the slides, all the pictures are available for you. Thank you very much.